It's wonderful to see so many people here, and I want to congratulate Octo for this wonderful event. I've spent time as a geek and as a boss, and I know that usually when those two groups get together, something has gone horribly wrong. And so it's actually nice to see that we're here not because the data center has exploded or something like that, but to talk about interesting topics. So I'm going to spend a little bit of time today talking about one of the things that we've done some research on. My role at the McKinsey Global Institute is to lead research on the impact of long-term technology trends, which we think will matter over the next coming 3, 5, 7, 10 years across different industry sectors. And for us, one of these trends is big data, and I think a lot of you have heard this term before. I'm going to describe some of the things that we found during about 6 months of research. We wrote this big report, which some folks might have read, and then have continued to do research on this topic, as well as start to engage with some of McKinsey's clients on these topics as well. I just wanted to share some of the things that we were able to find during the research, and also the things that we've continued to find as we've worked with clients on this topic. That being said, I'm hoping that we'll have a bit of a conversation afterwards, so feel free to tweet. I understand that questions will come up later, so feel free to ask those as they come. So that being said, what do we mean by big data? Well, first of all, it's probably not a surprise to anybody in this room, certainly not the geeks, and probably none of the bosses who have to pay for all this storage, that the amount of data available in the world has continued to increase over the past quarter century. But what's interesting about it, and it's worth reflecting on, is not only has the amount of data increased, but really the character of it has changed drastically. From being almost 100% analog to being 100% digital. And that has drastically changed the ways in which we can create value using data. As the McKinsey Global Institute, we spend some time trying to understand the technology trends themselves, but fundamentally we don't spend all of our time trying to understand what's the density on a disk drive platter, or what's the shape of the curve in terms of how much can be stored in static RAM. Really what we tried to understand was, how do you capture value from the use of big data? And so first of all, this idea of big data being an increase in volume is one of those things that we do think is important. It's an enabling trend. But we actually take a broader view in terms of what big data means, even beyond what we defined in the report, which is data beyond the scale at which traditional databases and other systems are challenged to manage it. We really do think that it involves, other folks have called it, variety and velocity, but this idea of an increasing diversity of sources and types of data, as well as its increasingly real-time nature. Number one, presents some challenges, particularly for the geeks in the room. It's hard to deal with all this data that's coming in different formats at increasingly high speeds, but it also presents a tremendous number of new ways in which you can create value. So some of these trends are as follows. Clearly, our traditional transactional databases continue to explode in size. All the structured data that we've had in relational databases for many years, that stuff's not going away, and in fact, it continues to increase. But then if you start to look at some of these other sources of data, we are seeing mobile devices. We're carrying, sometimes 2 or 3 of these things. And if you actually think about it, each of those devices, might have 5 or 6 different sensors in it, right? It has a GPS, has a camera, has a touch screen, has a microphone, maybe 2 cameras, often has an accelerometer. All of that stuff starts to generate more data, and it can be actually used with great value. And then social media, or just social in general. This is another area of study for us at the McKinsey Global Institute. But what's interesting about, this type of data, of course, is that it is unstructured. Tweets and pictures posted on a Facebook wall don't fit really nicely into the rows and columns in a traditional RDBMS. So, there's obviously been a lot of interesting innovations going on in trying to understand how to manage this data, how to ingest this data, integrate this data, and analyze this data. Again, unstructured as well as semi-structured and structured data, and being some of the trends which are important. And again, in terms of diversity of types of data, it's no longer just things that come, there's still ones and zeros underneath, but again, it's not just numbers and text. But we are increasing to see, video, for instance, audio, images. And again, our traditional ways of managing those types of managing data, it hasn't been as good at these types of data as well. But the volumes are immense. If you look at the internet backbone traffic, a lot of times over 50% of the bits carried on internet backbones are in fact video bits. And so again, we're seeing a burgeoning in terms of the types of data, as well as the sources and the speed at which it impinges upon us. Lots of stuff going on in scientific computing and visualization as well, generating more data. And then this trend that we've described as the Internet of Things, other people in the telco world have called it M2M, or machine to machine, or embedded computing. But again, as I said, not only are we finding a lot of sensors embedded in our mobile devices, but if you think about an automobile, a modern automobile is like a rolling computer network with wheels, right? You might have upwards of 100 processors and a likewise number of sensors in an automobile. It's not just automobiles, running shoes, bridges now are embedding sensors. And all of that data is generating more ways to create value as well. We use a bit of a funny term, you see it on the slide, exhaust data. I don't know if people have heard of this idea of data exhaust. Anyone? Perhaps some. I mean, the idea here really is the following. If you drive a car, and it's not a Nissan Leaf or a Tesla, you're going to have exhaust come out of the tailpipe. Because we are instrumenting our world increasingly, not only do you get exhaust coming out of a tailpipe, but you often just create data as part of the running a business or operating a piece of machinery. And sometimes people have created that data as a log file for maintenance reasons or what have you. But you can often find, and what we're starting to find, is that people are able to take that data which was captured for one purpose and then create value for it by trying to figure out where that value comes from. This could be things like search engine logs and Google flu trends, or it could be the logs that come out of a piece of machinery and trying to understand when that reveals it will need maintenance, and you can do some predictive analysis. But again, this idea of how do you monetize data exhaust is one that we're seeing over and over again. So now that being said, before we did this research, I think a lot of people would have said to us, okay, this big data thing, I kind of get it. It probably only matters in a few different parts of industries. I can understand how it might matter in financial services because those guys, the data centers, the factory, they've always just done a lot with data. And probably for consumer-facing industries, retail and consumer packaged goods, because for them, consumers just generate a lot of data. But then when we actually looked at the data, and this is US data, it's a similar set of statistics in Europe. In 15 out of 17 sectors, the average company, not the leading company, the average company with over 1,000 employees has more data in it than the US Library of Congress, which has every book that was published in the United States. And then for most of those sectors, they have more data available to it than existed in Walmart's enterprise data warehouse of only a few years ago. And if you understand that Walmart has been using data for many years as a way to compete by superior analytics in its supply chain, that actually suggests, and it suggests to us, that big data is a big deal in pretty much every sector of the economy and pretty much for every firm. In fact, as we did this research, we came to the opinion that the effective use of data is going to be a basis of competition going forward for pretty much every individual firm as well as sectors and economies. It's a bit of an aggressive statement, but what we're really saying is the companies that learn how to use data effectively are going to win in the marketplace. Those that don't are going to start to lose. And so it really matters pretty much for every company to learn how to use big data effectively. Now that being said, you hear the words big data, and I already explained that it's more than just volume, but you hear the words big data, and you might think of things like big government, or big brother, or big business, right? And we asked ourselves, does this trend only matter for the largest institutions in the world? And actually what we discovered as we started to do this research is that in fact, much like many other IT trends, not only does big data create a lot of value that can be captured by large institutions and organizations, but increasingly big data can be used by individuals. There's a company in the US, for instance, that talks about big data for the little guy. This is an example from healthcare, right? And this is a healthcare data that gets generated by something called a Fitbit. It's a little device that you can clip on your belt. It'll tell you how many calories you've burned as you walk around during the day. But the interesting thing is because you can upload that data into the cloud and basically do some big data analysis, you can start to benchmark your own health against those of other people around, well, certainly the United States or around the world for other people who have Fitbits. And so what we're starting to see are these applications where big data not only provides benefit to the largest institutions, but actually can provide benefit to individuals as well and individual consumers. So this is not a trend that's only for large companies. It's not only for small companies, but literally can provide real value to individuals. Now that being said, let me show a video in a moment here from a friend and colleague. His name is Erik Brynjolfsson. He's at the Massachusetts Institute of Technology, Sloan School of Business. He's going to talk a little bit about the fact, what I've illustrated here is that to a certain extent, a lot of the data that we have comes because we can instrument the world. And what he's going to suggest is the ability to instrument the world can create revolutions not only in science, but also in business.
Most great revolutions in science are preceded by revolutions in measurement. And we have had a revolution in measurement the past few years that have allowed businesses to understand in much more detail what their customers are doing, what their processes are doing, what their employees are doing. And that tremendous improvement in measurement is creating new opportunities to manage things differently. We've done research to look at some of the changes in the attitudes people have to how they make decisions. And we've found a shift from using intuition towards more using data and analytics in making decisions. And this change has been accompanied with a measurable improvement in productivity and other performance measures.
So listen to what he said there. The effective use of data, being more data-driven in your decision-making, has been statistically significantly correlated with higher returns on equity as well as higher productivity. So that being said, how did we try to investigate that? Because that was basically the hypothesis that we had as we were going into this research. Well, we would have liked to look at the entire economy, but in fact, we had to focus our search a little bit. We looked at a number of different places where we thought there were interesting uses of data and also a little bit of a variety. So we looked at the healthcare system, and I'll put that in quotation marks, in the United States. It's pretty complex, a lot of different stakeholders, a lot of different sources of data. We looked at European public sector administration. That's basically governments in Europe, and it's everyone who doesn't carry guns. We looked at retail with a North American focus. We looked at manufacturing with a global footprint. And then we also, those are all sectors. We also looked at personal location data, all this data that comes out of the fact we're carrying all these mobile devices around. And for each of those, we tried to understand at a fine-grained level, what are all the ways you could use data to create value? Whether it's value that gets captured by consumers or value that gets created for governments or companies. We tried to understand what they all were and came up with hundreds of them, of course, and we've sized them, and that's why that report is so big. But in addition, then we try to step back and synthesize and say, what are the principles? What are the ways in which you can create value using data, which could be applied to other sectors which we didn't study, for instance? So we found 5. The first one is simply creating transparency into data and analytics that you previously would not have had access to. Now this one seems pretty simple. I mean, how can that possibly be valuable? And yet when we look through the economy, there were large parts of the economy where the data simply, either wasn't in digital form. Despite that first chart I showed, there are still some places where the data is not in digital form, or it's not easily accessible. We studied some work groups where up to 25% of the activity were people trying to find data or bring it back to the right place, right? When I was a CIO, we used to call this sneaker net, right? You call around to a bunch of departments, then you run over there, burn a DVD, run it back, etc. A tremendous amount of waste that could be avoided if you actually had transparency, easy to access digital and big data. That being said, that power of transparency becomes even more powerful when combined with a second lever, which we've described as exposing variability and enabling experimentation. Exposing variability is fairly straightforward. It's just, find some comparable pieces of performance and just show people what's going on. It might be salesperson performance, or it might be the performance of different factories, or it might be performance of different shifts. Again, just this ability to expose that variability in performance. In the United States, for instance, we actually sometimes have an order of magnitude difference in price for the very same healthcare procedure in the same city. showing that variability can be extremely powerful, because then you can try to understand why that variability exists. And then, a lot of times you would say, well, what you have to do here is make sure you pay the people who are performing better more and incent them, and, maybe provide some, if not punishments, some disincentives to people who aren't, at the top of these league tables. Yet a lot of times that isn't necessary at all. All you need to do is have that transparency, because once you show that league table, nobody really wants to be on the bottom, right? It's a strong disincentive to find that you're at the bottom. So a lot of times just providing that transparency will provide a lot of uplift in performance. But the other thing that we've also discovered is not only can you just observe variability, you can actually start to create real experiments. And this is fundamentally changing the way a number of leading organizations are making decisions. We have a joke, it's a bit of an English joke, that most management decisions are made by hippos. Are people familiar with this? The highest paid person's opinion. Right? We sit around a table and we say we're looking at data, but in actual fact, when it comes time to make the decision, look at the person who has the biggest comp package, and they say, I've been in the industry for 40 years, here's what we're going to do. However, other companies that take big data seriously actually think about their organizations, which are instrumented, as being 24/7 laboratories. And the question then they ask in the management dialogue is, have you conducted an experiment there, right? Have you applied the scientific method, had a hypothesis about what would drive higher performance, tested it with a control group and a test group, and then analyzed the statistics afterwards in a rigorous way? And that's fundamentally changed the way a lot of these companies make decisions. There's a casino company called Caesars Entertainment. The CEO was a former Harvard Business School professor, Gary Loveman. He also jokes, look, there are two ways to get fired from my company. One is to steal from the casino, and two is to fail to have a control group in your management experiment. Again, fundamentally changing the way that management decisions are made through the use of data. Thirdly, segmenting populations to customize actions. Those of us who've ever done any marketing work, this is fairly standard. And yet, we found a tremendous number of instances where the idea of treating your customers differently, the idea of treating your suppliers differently, the idea of treating your employees differently, just seems strange to people, right? So in government, the idea that you would treat your citizens differently, oftentimes people react to that and say, that's not fair, you can't do that. Or utilities saying treating their ratepayers differently. Again, that seems very strange. And yet if you actually do customize your actions, you can often provide much better service, much more targeted service, and much more efficient and effective service than you possibly could before. Fourthly, replacing or segmenting or supporting human decision making with automated algorithms. Again, the geeks in the room, seems pretty straightforward, right? But again, we've used these types of techniques for many, many years. So for instance, trying to understand which insurance claims need to be audited. We do have some algorithms to do that. But increasingly, because of the diversity of data that we now have access to, and the fact that it's increasingly real time, allows us to create new types of algorithms, new innovations in terms of what are the ways in which we can, in an automated way, either replace, which is not always going to be the case, or at least support human decision making, including everything from physicians, having physicians assistant systems that suggest things around new standards of care which doctors might not be aware of. And finally, innovating new business models, products, and services. I mentioned before this idea of exhaust data, this data that just gets generated because we're actually running a business. And what's interesting is we're increasingly finding companies come up with business models that take advantage of that exhaust data for reasons other than why it was captured. So if you take an example of any company which is in a bit of an intermediary position between two players in a transaction. So payments players, for instance, which, by the way, I love the payments business. I don't know if there are payments people here, but money goes by and you get to keep a little bit as it goes by, right? But the other thing that's great about the payments business, not only is that you get to keep a little money as it goes by, but it generates a huge amount of exhaust data, which is tremendously valuable, because then you learn where people are spending their money, under what conditions, in what bundles, etc. And that's tremendously valuable to marketers, for instance. So we are starting to see payments players actually provide services again in an anonymized way, that provide some insight into where people are spending their money, et cetera, for marketing purposes. Or other companies like logistics companies that are just shipping packages around the world. They have a tremendous amount of information about the health of various economies, et cetera, et cetera, et cetera. Search engines, which are now starting to collect information about prices, can actually create an inflation index. So again, this idea of creating new business models by looking at your data in a different way than you originally thought can be quite powerful. Now, that all being said, is there any nascent evidence that in fact that statement I made before is true, which is going forward, the effective use of data is going to be a basis of competition? Well, this is a fairly gross analysis that just shows, from the outside in, based on press mentions, if you compare the speed and growth of the top line and bottom line of companies in a number of different, these happen to be consumer-facing industries, that the leader in using data in each of those industries versus all of their competitors. In general, we're starting to see evidence that the revenue growth rate is faster and the profitability growth rate is faster. Now again, as I said, this is a fairly gross analysis. Our friend Erik Brynjolfsson, in fact, did the detailed econometric modeling to control for a number of factors which aren't controlled for in this analysis, and yet continued to find a statistically significant correlation between how data-driven you are and how productive companies are, as well as their returns on equity. So does this add up to, any significant number of euros at all? We believe the answer is yes. Now, where in the value chain is all this? First of all, there's value everywhere. But I'll make a couple of points based on this chart. First of all, you can just simply sell the data. And there's lots of, you'd think, well, big data, that'll be a good business for big data, sell some data. And yes, that is valuable, right? You could see potentially tens of billions of dollars there. But where we really see a lot of the value, particularly when we did this research, is in how do you use that data to improve your business? How do you use it to market better? How is it that you use to reduce waste in your supply chain? How do you use that data in order to make sure your product development is, number one, more efficient, but more importantly, more targeted towards the needs that customers have? So that's really where a lot of the value comes from, that's hundreds of billions of dollars depending on the industry. And finally, there's this question about new business models. Again, the ability to capture value there is only going to be limited by one's imagination. But we do think that there's some real value there, and we're starting to see an increasing number of companies go after it. In terms of the research, what we actually found, again, big numbers here, but in the US healthcare system, for instance, the effective use of data could unlock up to 300, or actually in excess of 300 billion US dollars on an annual basis. In European public sector administration, over 250 billion euro on a run rate basis annually. Now, this doesn't just happen automatically, right? There are a number of other factors that have to be put in place in order for this to be effective. And yet we really did see potential value here if you are able to unlock some of the things that have to happen. Now that being said, that's an exciting story. Why hasn't it happened already, right? I mean, if there's so much value available, what are the barriers, or what are the enablers, to put it a different way, to making sure that this can actually happen? Well, the first one is, this idea of data policies, and this came up in the previous talk as well. But there is a bit of a, triumvirate of things you have to worry about, or not worry about, just take into account. Firstly, privacy. Clearly European data protection, for instance, it is actually quite challenging for multinational companies because privacy regulations are very different, and actually privacy laws are very different in different countries. And when we talk with clients about this, it's quite interesting. I mean, yes, that's challenging to deal with different privacy regulations in different places. But quite frankly, you just have to do it. Tough. That's unfortunate, but you just have to deal with it. But we don't actually think that's enough, right? That's just hygiene. That's just making sure you brush your teeth in the morning. What you really have to understand in order to effectively address privacy is what are the explicit as well as implicit contracts that you have with your various stakeholders, with consumers, your suppliers, your employees. And that's a lot trickier because that really is more about customer behavior or employee behavior, and et cetera. So understanding the psychology of that's very important. But again, we think just meeting the bar of the regulatory standards isn't enough. That's necessary, but not enough. Also data security. If data is going to be the basis of competition going forward, of course bad guys are going to try to achieve an unfair advantage by stealing your data, so dealing with that is going to be a challenge. And then of course intellectual property. Who owns the data? In some cases that's clear legally. For instance, in Europe it is clear that individuals have a right to their own data, but that's not true in every jurisdiction, and also different types of data fall under different regimes. So there are a set of data policy things that a company or an organization has to grapple with in order to be successful here. Secondly, technology and techniques. As I mentioned, not only is data, there's tremendous technical challenges with dealing the increasing volume of data, but now we're seeing a lot of innovation in terms of unstructured data analysis, et cetera, Hadoop. I mean, it's interesting because, we now hear CEOs telling their CIOs, can you get me one of those Hadoop things? I think it's really valuable. At least they have awareness, right? Even if they don't have a deep understanding. But all this idea of an increasing amount of innovation that will allow you to use the large amounts of data that are unstructured effectively is another thing that you'll have to understand. Thirdly, access to data. Another finding from our research is, if you ask any executive, look, what percentage of the value are you getting from the data you already have? And most of them will say a very small percentage. We're barely scratching the surface. And yet what we also found was that you can usually multiply the value you capture from data when you combine data from external sources with data that you have within your four walls. And so again, we think going forward that a key core competency for a company is going to be able to figure out compelling value propositions so other people will share data with you. Right? Being able to figure out how to make sure that people will share the data with you that allow you to create value. Just a couple examples of that, right? Those of us who have Facebook accounts, Facebook gets a lot of its value from data that we freely provide to Facebook, right? We don't actually get paid for that directly. So what has happened? Well, they somehow have created a value proposition where it's valuable enough for me to use the service and provide data that I'm willing to do that. Or for instance, I spent some time with the CEO of Procter & Gamble, and we published this article, this interview in the McKinsey Quarterly. And he said, look, when I do a business deal, I actually think of data as being part of the currency, right? I might give up some price because I actually think the data is that valuable. So again, going forward, we think this ability to understand how to unlock data from external sources is going to be a core competency. And then finally, organizational change and talent. I already mentioned that companies that use data effectively make decisions in very different ways. And that's not hard. That's not easy to do, to change the way that companies or individuals or successful executives make decisions. But we also found another pressing issue, which is when we talked to companies that were leaders in using big data, they said it's getting harder and harder to find talent and keep talent. These people who can take large amounts of data and analyze it and derive business insight from it. And that's a tremendous challenge because, well, it's a challenge, but it's also an opportunity. Given that these people are becoming more and more scarce, if in fact you can hire those people and retain them, you're going to have a competitive weapon going forward. So I want to show another video in a moment here, which is about of someone who was a big data leader. He was one of the first analytics folks at Facebook, and he now is one of the co-founders of a company called Cloudera, which is a Hadoop-based company. He's going to talk a little bit about a new set of a new set of job titles called data scientists. And it's funny, Hal Varian, the chief economist at Google, says, look, for the past 10 or 20 years, if you wanted your kid to be successful, make sure they have a computer science degree, right? Make sure that they can code. And he says, look, for the next 10 years, the sexy job are going to be statisticians.
At Facebook, I was the first research scientist. The initial goals for my position were to understand how changes to the site were impacting user behavior. Where I tried to articulate, the infrastructure that we did build out at Facebook and the kinds of people that we were looking for in this title of data scientist. I actually see people sort of self-describing in their job titles on LinkedIn, or I'll even go to discussions with scientists working on like data-intensive science is a field that I'm pretty interested in, and I'll see them talking about themselves as data scientists. So it's pretty interesting. So I think it is evolving. It's taking hold. I think people do realize that there was a gap between what the title of statistician or data analyst or business analyst represented, or even data mining, and what they actually wanted. So it was kind of that combination of the whole research cycle that social scientists had, plus some additional programming skills, plus the ability to do aggressive prioritization. It was a lot of what we were looking for. And of course, we expected sort of a good grounding in statistics and machine learning. So that was kind of the table stakes. So that sort of, that collection of skills was difficult to find.
That collection of skills is difficult to find. We heard that over and over again when we talked to companies that wanted to use big data effectively. So again, we do think that this is an important enabler in order to capture value. And it has interesting implications not only for companies, again, if you have these people, you'll have a competitive weapon, but indeed for countries. If you want your country to be successful in a big data world, you're going to have make sure you're graduating or immigrating enough of these people. So that being said, we wanted to run a little bit of analytics against this and say, that's the anecdote, that's what people are saying. Is it in fact true? So again, we did this analysis based on US data simply because the data was most available there. But we've also looked at different countries and found some interesting findings. But basically the same thing is true, which is that the supply and demand gap is widening. So what we did was look at all of the people, let's take just deep analytical skills, people with advanced training in statistics or machine learning, the sexy jobs, or rock stars as some people have called it, data scientists. And if you look at all those people that are existing in the economy right now, and how many of them will exist in another 6 years at current course and speed, because of people graduating, people immigrating, net of people leaving the workforce or leaving the country, et cetera. And you compare that to the demand for these people in a big data world, a world in which the effective use of data is going to be a basis of competition. If you look at that, those two curves, in another 5 or 6 years in the US, you're going to see a gap of maybe 150, say 140 to 190,000 positions. Similar kind of thing in Europe. Right? So what that suggests is you need to find these people, and it suggests perhaps the policymakers, we need to make sure we're graduating more of these people. So that's the big data analysts. Again, not only do you need people who have these master's degrees and PhDs in these fields, but you need to fundamentally change the way that managers and executives make decisions. And so again, if you take a look at, they don't have to spend years studying this stuff, but have to understand enough things that, what does conditional probability mean? What's the difference between a type 1 and type 2 error? How do you determine causality versus correlation? I sometimes joke we should stop teaching so much calculus. In the US anyway, people take a lot of calculus and very little statistics, but which one is more valuable unless you're doing some engineering? Which one really will help you make decisions in an increasingly complex and murky world? I'd argue that it has a lot more to do with your statistical skills than it would with your calculus skills. So that being said, executives and managers, those that have these types of skills, those that at current course and speed will have those types of skills in the next 5 or 6 years, versus the need for those types of people to be smart big data consumers in a big data world. Again, we're sizing maybe 1.5 million of these people in terms of a gap. Now, fortunately, it doesn't take years to give someone who has some numerical skills this training, and yet we're not yet there, and so it'll be important to be able to do that. And finally, we need geeks too, right? So the people who actually run the hardware, run the software, manage the data as well. So that all being said, what are the sorts of things that we're seeing some companies do as they think about how to take advantage of this big data opportunity? Because one of the things that Jeff said is that you need to have the ability to do aggressive prioritization. Why is that? Because once people learn that you or a unit has this capability within your organization, you are automatically going to be oversubscribed, because this stuff is applicable pretty much across the entire business. So sometimes the hardest things for these people is to figure out what they should work on next, because they're going to create value wherever they go. So that being said, what are we seeing companies do? First of all, 1 and 2 here are oftentimes is a bit of an iterative process, right? Auditing or inventorying data assets, not only ones that you have internally, but ones that you could have access to, whether it's proprietary or purchased or public, right? It could be data from the government, it could be data that you get from a business partner, et cetera. Just understanding what data you have available in or around your organization. But then also coupling that with trying to understand, well, what problems could I solve if I had that data? Sometimes, as I said, it's an iterative process. Wow, I really wish I could reduce my churn rate. To do that, I need X, Y, and Z data. Oh, I do have access to that, but if I had access to that data, maybe I could solve this other problem. So just being able to create that universe of possibilities is something that we often spend quite a bit of time with. The third thing is building those internal capabilities, whether it's technology or talent. All those things are going to be important. You can't actually capture value unless you have those capabilities. And again, it's described as internal. Obviously, you can also use external providers in order to capture this capability. Fourthly, addressing those data policy issues, whether it's privacy, intellectual property, or security. Fifthly, demonstrating value. I mean, one of the other things that we discovered is that the companies that are leading and using this field, they aren't ones that say, oh, great, this is a great idea. Give me 5 years and I'll come back with my data warehouse and it'll be perfect and we can start doing some stuff. That actually doesn't seem to work very well. And in fact, in many cases, companies tend to over-specify data quality. Data quality is very important, but in general, a lot of data quality gets specified by people who, for whom it's too important. So take, for example, financial services. You can never get somebody's account balance wrong, right? That's unacceptable. But you don't need 100% accuracy in order to actually drive some marketing performance, right? To increase the conversion rate. So making sure that you match your data quality requirements with the application is very important. And so again, that's why some people say, oh, it'll take 5 years to get this done, right? Because they think, I've got to scrub all this data. But in fact, that's actually not necessarily, and in many cases, not what you need to do in order to capture value. And so, I give a bit of an example, which is, this year is an election year in many countries, including this one. And, big data has fundamentally changed the way in which elections are won in many cases, right? And look, you don't have 5 years, right? The election's this year. So what do a lot of these, campaigns do? Well, they throw a bunch of data and throw a bunch of 20-something-year-olds in a room and say, look, I need votes, right? And they actually are able to use this dirty data and do the analysis in order to capture some value. So this idea of experimentation, which by the way is different than the idea of a pilot, because to me a pilot connotes, here's where I'm going and I'm going to go to definitely, step 2 and step 3, et cetera. Experiments are successful even if you learn something negative. It's like, oh, that didn't work. I learned something. So demonstrating value is very important. But then once you are able to find value, being able to architect a transformation so you scale that value up writ large. So let me pause here. But basically what I've tried to illustrate here is that it is a new trend. It is one that's followed the past. But the increasing diversity, the increasing speed, and the increasing volume of data has created new ways of creating value. And we think it's a big deal. Big data is a big deal for pretty much every company in the economy.